Tamperproof projects. In this video, we are going to explain about the project that is cybersecurity anomaly detection, AI, and Ethereum blockchain for a secure and tamper-proof IoHT data management. So, before getting into the execution, first let us understand what is the project about. So, IoHT, that is Internet of Healthcare Things, it is basically the network of smart medical devices that can communicate with each other. So think of things like wearable health trackers, remote monitoring devices, smart hospital beds, and even AI-powered diagnostic tools. So they all work together, they collect, they share, and analyze patient data in real time, which makes healthcare more efficient and accessible. But here the catch is, that is, here the problem is, the more connected these devices are, the more vulnerable they become. We're talking about serious security risks like unauthorized access, hacking attempts, and also data breaches. Imagine if a hacker gains access to a pacemaker or a hospital's patient records. That's not just a privacy issue, it's a life threatening problem. So, traditional security methods like basic passwords or firewalls, they aren't enough anymore because cyber threats are becoming more advanced. These systems need real time threat detection and stronger authentication mechanisms to keep sensitive patient data safe. Otherwise, the entire system is left open to cyber attacks, risking both patient confidentiality and also the integrity of the medical information. And one of the biggest challenges, that is the problems with IoHT, is that it relies on centralized systems. Basically, all the data from different medical devices like patient monitors, smart wearables, or the hospital systems gets sent to a single centralized server. Now, that might sound convenient, but the problem is if that one system fails, which we call as a single point of failure, that is SPOF, everything crashes. That could mean losing access to critical patient data or even causing delays in the emergency care. And another issue is the false systems permissions and privacy risks. So the another issue is false system permissions and privacy risk. Sometimes the system might wrongly allow an unauthorized device or a person to access the sensitive patient information without proper checks in place. So hackers or malicious insiders can exploit these weak points, leading to potential data breaches. And to make things worse, there is no universal standard for security in IoHT, so different systems might have different levels of protection, leaving gaps that attackers can take advantage of. So, to tackle the security issues in IoT healthcare systems, this project combines Ethereum blockchain, IPFS, that is interplanetary file storage, and AI based anomaly detection to make sure that the data remains secure and tamper proof. So, first, let's talk about how blockchain helps with the security. IoT devices like smart sensors in the healthcare, they collect the data, which is need to be stored. So instead of storing the actual data in the blockchain, which could take a very large space, that is, which could get very large, IPFS has been used in this project. So that is called as interplanetary file system. So IPFS is like a decentralized storage system, meaning the data is spread out across multiple locations, making it harder to hack or tamper with. So what the blockchain actually does here is it just stores the addresses where the data is kept on IPFS. So this keeps things secure and also lightweight. Now every time the data is stored, a unique hash code is created and that hash code is saved in the blockchain. If someone tries to change the data, the hash won't match when checked, so the system will immediately know something is wrong. Now, for AI-based anomaly detection part, once the data is safely stored in the IPFS, which is linked onto the blockchain, AI comes into the play. So the data is pulled from IPFS and then fed into multiple machine learning models like support vector machine, random forest, and others to spot any unusual activity or anomalies. So these algorithms, they can identify if something doesn't seem right, like a hacker trying to manipulate the data. And here we have used IoT ton dataset to detect the anomalies. So this dataset first initially it will be stored in the IPFS and that hash code will be stored in the blockchain securely. And by combining blockchain with AI, the system makes sure that data integrity and data security are maintained. The data is protected from tampering and AI helps to detect any threats. So this setup helps keep IoT healthcare systems safe, ensuring that sensitive patient data is stored securely and privacy is always protected. So this is the proposed system part. Now moving on to the extension to further improve the performance, here CatBoost algorithm has been incorporated to take the anomaly detection to the next level. So here we have used this CatBoost to increase the accuracy of this project. So cat boost is a type of gradient boosting algorithm that is really good at handling features efficiently. It improves the overall performance by not only increasing the accuracy but also optimizing how quickly the system can make the predictions. So this means the system can spot anomalies more accurately and faster, making it even more reliable for detecting any security breaches or data manipulation. And on top of that, a Flask-based front-end interface is developed for user testing. This lets users to interact with the system, test its functionality, and provide feedback. So here, this front end also includes the secure authentication mechanism to ensure that only authorized users can access the system, keeping everything safe and protected. So this extension not only enhances the technical side of the anomaly detection with the cat boost, but also makes the system more user-friendly and secure for testing and evaluation purpose. Now, moving on to the implementation. To implement this project, we have followed the steps mentioned in the flow of work. So first, we have imported all the necessary libraries and packages. So these include packages for data manipulation, machine learning models, and blockchain related functionality. Then comes data collection part. So a connection to the interplanetary file system, that is IPFS, is established to store the IoT data in a decentralized manner. And then a smart contract is deployed on the Ethereum blockchain to securely store and retrieve the IoT data, with only IPFS addresses being stored on the blockchain. And IoT data is uploaded to IPFS and its unique addresses is saved onto the blockchain for tamper-proof storage. And then comes the data retrieval part. So here the IoT data is retrieved from the IPFS through the blockchain smart contract by using stored addresses. And then the retrieved data is then converted into structured format for easy processing. Then comes data processing part. So here the dataset containing IoT sensors reading is loaded from for further processing. Then comes the label encoding. So here categorical data is converted into numerical values to make it suitable for machine learning models. And then feature values are scaled to a range of use 0 and 1 using min-max scaling to improve the model performance. Then comes the shuffling part. So the data set is shuffled to ensure randomness and avoid any potential bias in training. Then we split the data into train and test. So here training set is used to train the model and testing set is used to evaluate the model. And 80% of the data is assigned to training set and remaining 20% for testing the models. Then comes building the model. So here different machine learning models are built to detect the anomaly in the IoT data. That is here we will be initiating the models. Then comes model training. So here we train the data set using the models. That is machine learning models, random forest, support vector machine, decision tree, etc. So this helps to learn the patterns in the data for anomaly detection. Then comes model evaluation. So here the trained models are evaluated on the test set of the data set and they are evaluated using accuracy, precision, recall, and FN score. So these are calculated to assess the model performance. And then confusion matrix is displayed to visualize and analyze the model's classification performance. Then comes the front end part. So here a front end interface is built using the Flask framework, including user registration and login functionality stored in an SQLite database. And in the front end users, they will be able to provide test cases and that will be pre-processed at the backend. It will be fed with the trained model. Finally, outcome will be displayed detecting the anomaly. So this is how we have implemented the project. Now moving on to the algorithms used. These are the algorithms used in the project. So these are the proposed models and this is the extension model. And to implement this project, we need basic requirements that are hardware and software. So coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Python, front-end framework of Flask, backend framework Jupyter Notebook, database SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute. To execute, we are supposed to open the code folder which contains source code files. So let's open the code folder of the project. So these are the source code files in the code folder of the project. So in this folder, we have the dataset that is used in the project. So let's open it. So this is the dataset that we have used, and this is the test data that we will be using in the front end for detecting the anomaly. Let's get back. And this is the HelloEth folder. In this folder, I have node module folder. This folder consists of dependencies or modules needed for the project. So this is the node modules folder. And here in this folder, I have .bin folder. So this .bin folder contains executable scripts related to project's dependencies. And in that, we will be having run blockchain.bat file that is used to execute the blockchain. So already we have stored the data in the blockchain. And it also contains commands to start the blockchain environment. And this is the Solidity code. So it handles data structures, functions, and events with modifiers for validation. And here in the model folder, we have the algorithm information that is stored in .h5 files, numpy files, and pickle files that will be loaded into the project code during runtime of the application. And this is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And this is the IPFS file in which we will be storing the dataset. And the address of that dataset is stored in the blockchain. And this is main.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And this is the Jupyter Notebook file in which we have a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a proper choice for the data science. And this is the Windows bat file. Instead of executing project through command line interface, we have created this Windows bat file. So just by double clicking on that, we can run this project. So double click on that. Here you can observe, right, main.py file has been compiled. So now the Flask framework will host the application locally at the default address, which is the localhost and the port unless configured differently. So this is the localhost and this is the port. Now we need to copy this local link provided by the Flask framework and paste it into any web browser. So I'm copying the link. I prefer Google Chrome, so I will paste it in that. So paste the link here. At the end, type index and click on enter. So this is the web page of the project, which is displayed in the browser, and this web page is developed using Flask framework. So we need to first log in as admin, click on admin login and give the username and the password of admin. So I'm giving the username and the password. Now click on login. We have logged in successfully and we are redirected to detection page of the project. So here you can see IoT anomaly detection link, right? We need to click on that for uploading the test data. So let's click on IoT anomaly detection. Here you can see choose file button, right? We need to click on that for uploading. So before uploading, let's see what is the data that we have in test data. So here in this dataset folder, we have test data. This file only we will be uploading now. So let's open this. So these are different test cases that we will be giving as input to detect the anomaly. So let's get back. Now click on choose file. So this is the file that we will be uploading. Click on open. It has been loaded. Now click on submit. So here we got the prediction. So before getting the prediction, let's get back to the test folder. So here we have date, time, temperature, pressure, and humidity. So these are the inputs we have given. And here total we have 15, that is 14 test cases. Let's get back to the application. And here you can observe, right? So here for all the 14 cases, we got the output. So for the first case that we have given here, we got the prediction that DDoS attack has been predicted. So here attack has been detected and that attack type is DDoS attack. And for the second case, the second input that we have given, a backdoor attack has been detected. And for the third case, you can observe that injection attack has been predicted. And for the fourth case, also same injection attack. And for this case, for this test data here, there is no attack. So that is why it is showing that normal. And for this case, it is predicting that a scanning attack. So here there is an attack detected and that attack type is scanning attack. And for this case, XSS attack has been detected. So for this case, XSS attack has been detected. And here in this case, there is no attack. That is why it is predicting as normal. And in this case, here you can observe a ransomware attack has been detected. And also for the next case, ransomware attack is detected. And here scanning attack is detected. Here for this case, XSS attack has been detected. For this case, DOS, and for this case, backdoor. So now click on logout. In this widget, by giving input to the application based on the given input, the application will predict whether there is attack or not. If there is attack, that is anomaly, it will detect which type of attack it is, whether it is DDoS attack, scanning attack, injection attack, or any other attack. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.